Antiderivatives are not unique. Suppose I want a function who has a derivative of 3x squared. Well, let's look at these three and see which one of these might possibly be the answer. The derivative with respect to x of x cubed is 3x squared. So this is one answer. The derivative with respect to x of x cubed minus 5, well, that's also 3x squared plus 0, but I'm going to drop off that 0. So this is also a function who has a derivative of 3x squared. Let me look at f3. The derivative with respect to x of x cubed plus 97 is 3x squared plus 0. So this one is also a function who has a derivative of 3x squared. So if a derivative goes in one direction, the antiderivative goes in the opposite direction, and we say that a function has an antiderivative of f if f prime is equal to f of x for all x and I. Now we've been using the and notation, not the antiderivative, because it turns out all antiderivatives of f, suppose f and g are antiderivatives, then all of them are separated by a constant. So let's look at this. If g of x is equal to f of x plus c, then if I take the derivative with respect to x of g of x and the derivative with respect to x of f of x, plus c, let me erase that. Then I get g prime is equal to f prime plus 0. So all antiderivatives of f vary at most by a constant c. So let's talk about what we mean by differential equations. A differential equation is just an equation that involves y prime. It can be as simple as y prime equals 2, y prime plus y equals x, y prime plus 2xy equals 72y cubed. I mean, it can get really ugly. So when I say a differential equation, I just mean that there's a y prime in there. So suppose I want to solve the differential equation, y prime is 2. What I'm really saying is d dx of y is 2. What function has an antiderivative of 2? And of course, that is when y is equal to 2x plus some constant. Now I'm going to check this. D dx of y is d dx of 2x plus c. So this is just 2 plus 0. Let's look at what this means practically. If I have y prime equals 2, what does this say? This says the slope is 2. And there are an infinite number of lines who have a slope of 2. It just is a matter of changing the plus c. So let's look at the notation for antiderivatives. And we're going to get on to indefinite integration. That's where we're heading. If dy dx is f of x, and then we put dy in differential form, dy is f of x dx, then we find the antiderivative, this is the antiderivative, of f plus c is equal to the integral of f of x dx, where f of x is my integrand and dx is my variable of integration. You know the way things go. We may integrate in y, we could integrate in z, we can make up our own letter.